solve the initial value problem. Y double prime plus 2y prime minus 15y equals 6 delta t minus 1, and the initial conditions are y at 0 equals 0, y prime at 0 equals 2. Okay, first we take Laplace transforms of both sides of this differential equation. Okay, take Laplace transform of both sides, we get Laplace of y double prime, because Laplace is linear, plus 2 Laplace of y prime minus 15 Laplace of y is equal to right hand side 6 Laplace of delta t minus 1. Next, using the table, Laplace of y double prime is s square ly minus sy0 minus y prime 0 plus 2 Laplace of y prime. Again, using the table, we get s Laplace of y minus y0 minus 15 Laplace of y equals 6 Laplace of this Dirac-Delta function delta t minus 1, using the table. So we have the formula over here. Laplace of delta t minus c is e raised to negative cs. So c is 1, so e raised to negative 1s, just s. Next, let's use the initial values. Y at 0 equals 0, so this is just 0, and this is also 0 times s, this is whole 0, and y prime 0 is 2. Now let's rewrite. At the same time, we can factor ly out from this first, and here ly, and here. That will be always the case. We factor ly out, then we get s squared is plus, because we need to distribute 2 inside. This is 0, so we need to distribute 2, so 2s minus 15, and what survives here, this is 0 minus 2, that's minus 2, that's outside of ly, minus 2 is equal to right hand side 6 e raised to negative s. Now we are supposed to isolate ly, then take the inverse Laplace and get y back. So let's move 2 to the other side, this negative 2 becomes plus 2, and divide by this factor. So we get ly is equal to negative 2, move to the other side, plus 2, so 6 e to the negative s plus 2, and divided by this factor, s squared plus 2s minus 15. Now to recover, or to get the solution, or to get the answer y is a function of t, we need to find the inverse Laplace of this function. Okay, that's the next part now. Now to find the inverse Laplace transform of the right hand side, we have 2 terms on the top and 1 term, this one polynomial on the bottom. We are supposed to separate into 2, but this is just the product of 2 factors. So instead of separating into 2, let's write in this way, so that we can write partial fraction decomposition for this, okay, because this is complex fraction. So let's write in this way, 6 e to the negative s plus 2 times 1 over s squared plus 2s minus 15. Okay, now let's write this fraction as a sum of 2 simpler fractions. Do the partial fraction decomposition over here. This one factor says s plus 2, s plus 5 times s minus 3. Here is the work. Then if we say, let's say this is just fs for a moment, this is 6 e to the negative s plus 2 times fs, just 1 over s square plus 2s minus 15, and we worked over here. So fs is in fact this fraction, and when we write into sum of two simpler fractions, we get negative 1/8, because a is negative 1/8, 1 over s plus 5, plus b is 1/8, 1 over s minus 3. Now we can take the inverse Laplace of this. This implies the inverse Laplace of uppercase f, ft. Inverse Laplace is negative 1 over 8, and this is coming from the negative e to the 5t plus 1/8 e to the 3t. Okay, now this is L of y. Back here, take the inverse Laplace of both sides, then y is inverse Laplace of, we can write into 2, but this fs is for both. So inverse Laplace of 6 e to the negative s fs plus inverse Laplace of 2 fs. Okay, that is same as 6 can be pulled all the way to the front. Now we need to take inverse Laplace of e to the negative s fs. Come back here, look at this formula. Okay, Laplace of uct, unit step function at center at c, ft t minus c, is e to the negative cs fs, and we are exactly in this form. Whenever we have e to the negative cs times fs and take the inverse Laplace, we get unit step function at c, and the function, this little f, is the inverse Laplace of uppercase f, but t minus c. So using this formula, we get unit step function. Let me use a different color. Unit step function u at 1 t, and f t minus c, little f, t minus 1, and our little f is in fact here, plus this 2 outside, and inverse Laplace of upper f is lower f t, and f t is given here. That's how we get final answer. So 6 u1t, f t minus 1 is just this, but t should be replaced by t minus 1. That's negative 1/8 e to the negative 5t minus 1 plus 1/8 e to the 3t minus 1, just for that part, plus 2 times ft. Ft is here, so negative 1/8 e to the negative 5t plus 1/8 e to the 3t. Final. This is the solution of the given differential equation.